Hello everyone. Today I want to introduce you about the audiovisual processing in human Planum temporal using high-resolution fMRI. I have nothing to disclose. First, where is the Planum temporal located in humans? Roughly, it's in the auditory association cortex. In this anatomical EPI image, you can identify the landmarks in auditory cortex, such as the first and second transverse gyrus of Herschel. These two gyrus divide the auditory cortex into three subfields, as T1, T2, and T3. T3 is where Planum temporal located. Our first question on PT is about the sensory-specific topographical distribution. We use columnar analysis, divide the cortical ribbon in PT into hundreds of small stripes from posterior to anterior. Here, column is a simple dimension perpendicular to cortical depth, which does not have any neuroscience meaning. Then we extract the signal change for visual and auditory input and check if these two profiles are separated or overlapped. Here is the group results. The curves in different colors represent different stimulation conditions. You can see visual-only condition activated more posterior PT as shown by the blue curve, while the red curve of audio-only condition have more activation in anterior PT. It's clearly shown the response peak of audio-only and visual-only are segregated rather than overlapped. Our second question is about the laminar response in different subareas of PT induced by the stimuli of different sensory modalities. Based on the columnar profile, we can divide the PT into two sub-area ROIs as posterior and anterior PT. Based on the signal change across cortical depths, we can distinguish between feed-forward and feedback projection types. Because both signal is strongly biased toward the corporeal surface, here we measure an additional contrast from the same scale of both, which is vapor. As demonstrated in our previous study, vapor contrast is much less biased toward the superficial layer and compared to both and shows a better laminar specificity. In ROI of anterior PT, both audio-only and audio-visual stimuli induced a strong signal change in middle layers, suggesting a similar feed-forward input. This makes sense as the auditory inputs for these two conditions are identical. Second, the signal changes in superficial layers are dramatically different between audio-only and audio-visual condition. It suggests a strong feedback signal change present in audio-only condition while is absent in the multisensory condition. And this difference depends on the task performance like response time. Audio has a much poor spatial resolution than visual and is very noisy during scanning. This high uncertainty in bottom-up inputs requires a top-down feedback from high-out areas to help the subject to detect the auditory motion direction. Giving no response to visual inputs in this area, the feedback signals are unlikely to come from visual cortex. In posterior PT, we see a significant activity induced by visual inputs. These activity patterns show a feature of two stripes consistently across subjects and across different scans in each subject. This bilaminar activity pattern can be explained by the feedback projection from visual cortex. In monkey trace study, it has been shown that this feedback projection from visual cortex mostly terminated in TPT or CPB, which corresponds to the PT areas in humans. In conclusion, we found a division of function between visual and auditory processing in anterior and posterior PT, and also distinct feedback mechanisms in these two different subareas. Thank you.